Our material is lead in a lead acid battery. My name is Annette Winterland.
I'm Lillian Slack.
I'm Lexi Riam.
I'm Erica Salisbury.
And I'm Claire Wilson.
The functional unit would be 10 kilograms of lead in a car battery that can hold up to 12 volts of power and last for 10 to 20 years or for at least 100,000 miles of driving.
Lead is used in the greatest quantities per unit in batteries, radiation shielding and weights, and used in lower quantities per unit in lead crystal glass and ammunition. The top producers are China, Australia, and the US. EPA has current regulations involving lead quantities in paint, water, and air, and also lead disposal and cleanup because it can be toxic to humans and ecosystems. The United Nations Environmental Program has had initiatives to aid nations who are impacted by lead exposure from recycling and smelting. And the environmental impacts include toxicity to organisms, pollution to groundwater, crops and soil, and greenhouse gas emissions from the lead life cycle.
Here in the US, we have extensive policy and regulations regarding the use of lead in products, but we are only one of 43% of countries that have laws to limit the production, import, and sales of lead paints as of December 31st, 2021. This figure exhibits other countries' limited knowledge of the effects of lead. This lack of regulation can have deadly consequences, as it is estimated that 1 million people die annually from lead poisoning, with children and pregnant women being the most vulnerable. As consumers, it is important that we be aware of how these products we consume are affecting the people and environment around us. Shown here is our stakeholder map, where we have identified 10 stakeholders as shown. Our notables were the EPA and electric vehicle consumers. The EPA has lots to look over and create or change regulations, so that's why we put them at high power, but due to their significant scope, lead isn't their top priority, which is why we put them in lower interest. And consumers have high interest but medium power due to the politics surrounding the electric vehicle industry.
So this is our overall system diagram where we have noted each phase with the material and energy inputs, as well as material outputs and CO2 equivalent emissions. It's also important to note that lead is a highly recycled material, which is shown by the line leading from the recovered materials at the end of life to the manufacturing phase. So in the United States, there are currently 5 lead mines, which are all located in Missouri. And in 2022, the U.S. Geological Survey noted that there were 280,000 metric tons of lead mined in the U.S. Lead ore is extracted in open pit or underground mines, and it's extracted by drilling or blasting dynamite. And the ore is then hauled to be brought to the surface and transported for processing. However, in lead ores, there's only 4% recoverable lead, so there's a lot of waste product, which includes waste rock, which can be used for constructing roads within mining sites. And due to the recoverability of lead in the ore, 250 kilograms of lead ore is needed for the 10 kilograms of lead in our functional unit. There are 3 main stages to lead processing, which include ore concentration, smelting, and refining. Each phase involves different processes, including froth flotation, smelting, and refining, and each phase results in a higher concentration of lead to eventually result in refined lead, which is 99% pure.
The lead acid batteries at their end of life are packaged and sent to an EPA-regulated facility where they undergo a process called smelting. This process first starts with safety checks from workers to ensure that only lead acid batteries are going through the recycling phase. The acid from the battery is then drained and collected after a large machine breaks down the battery into smaller pieces. Then the parts are dumped into a water-filled vat where the plastic parts float to the top and the lead parts sink to the bottom. The reclaimed lead will then be smelted and reused in new batteries after leaving the vat. The lead is now formed into molds called ingots after adding additional elements to create alloys. These newly formed lead molds will then be taken to manufacturing companies to create new lead acid batteries by melting the molds into battery grids. An example of a corporation that uses this process is EnerSys. They are a leading maker of industrial batteries for applications including motive power and have facilities all over the world that assemble and recycle lead acid batteries. Since over 99% of lead is recycled, there isn't too much lead that becomes hazardous. However, if the lead in car batteries isn't recycled, lead can end up in landfills or leak into the environment, where it can contaminate soil and water sources, leading to lead poisoning in different species.
This is our impact assessment. The table includes the total values for each category added from all phases. Two categories we would like to highlight are climate change and human toxicity. Much of the climate change impact comes from the manufacturing phase. One way to decrease this impact is to obtain energy from renewable sources. Human toxicity mainly comes from the end of life and extraction phases due to contamination into surrounding communities. Ways to decrease this impact is to invest money to make recycling plants safer for the workers and surrounding community in the end of life phase, and to reduce contamination of water from mining sites in the extraction phase.
In order to normalize the impact categories, we use the values from the RECIPE database, which shows the impacts at a global scale since the lead life cycle has impacts all over the world. The most important weighted categories were human toxicity and climate change because these categories directly affect either human health or have global implications. Some less important categories include the depletion of metals. Since lead is the most recycled material, there will not be a significant depletion of metals. It makes sense that the eco score is small since it is weighted against impacts globally, but the manufacturing of significant amounts of lead acid batteries will have a great impact on the environment and human health.
This is a chart of the cost of the manufacturing phase projected over the lifetime of the battery. These costs will have different effects on the stakeholders and their decisions. Since the cost of greenhouse gas emissions is much higher than energy, the companies may choose to get their energy from green sources. Doing this may increase the cost of energy slightly, but will decrease the cost of greenhouse gas emissions more. Other stakeholders, such as the EPA and EV consumers, will have a favorable opinion toward this decision. The cost of lead is the highest cost by a large margin, so lead distributing companies and battery production companies may try to cut costs by using lower quality lead, which would have a negative impact on EV companies and consumers. They may also try to unethically dispose of the lead to cut costs, which will have an impact on surrounding communities.
For the sensitivity analysis, we analyzed the effect of the weight of lead in the battery on the climate change impact. We found that increasing the weight of lead in the battery will also increase the climate change impacts of the lead life cycle. A larger battery would allow for greater amounts of energy to be stored by the EV. However, this will also weigh down the vehicle, requiring more electricity to be produced for driving. Therefore, increasing the weight will likely be ineffective and unnecessary.
So our other interpretation factor is recycling. And as we've previously mentioned, the effects of non-recycled lead can lead to significant contamination to the environment surrounding the landfills, which affects the communities around it too. However, recycling these batteries can also have a lasting effect on the people around it and the planet that it is home to. As we previously mentioned, the lead is usually sent to EPA regulated facilities. However, a common way to cut cost is to send it outside of the United States. Since the recycling involves smelting and separating a lot of contact is had with the lead, a lot of contact is had with the lead from the workers, which, as we know, can be deadly. So while recycling of lead is necessary to prevent accidental contamination, it is important to be aware that the recycling can still be refined and made better and safer to the people involved with it.
During our research process, we mainly relied on previous LCAs and government studies on lead to find data for all the phases of the life cycle, the impact assessment, and the weighting matrix. The source we relied on most was an LCA comparing lithium ion and lead acid batteries.
Our group came to the conclusion that lead is used in batteries for electric vehicles, which seemingly would save the environment, but in reality, it is quite the opposite. While lead is one of the most recycled materials, it still has extreme negative impacts on human health, greenhouse gas emissions, and other impact categories. To the right, we have created a graph that is the normalized impact values of lead, which ranges from climate change to particulate matter impact categories.
And for further research, we have noted that we would have liked to include impacts of lead acid batteries versus other types of EV batteries, ways to better facilitate recycling processes to reduce human health impacts, and how the substitution process of recycled lead reduces impacts of lead mining. And here are our sources.
Thank you.